everybody, welcome back. I'm going to try and take up some of the homework from last night first, looking at oxidation numbers, and then I'm going to move on to a very short note today, and then I'm going to leave you with some homework again just to review everything we've done so far on redox reactions, oxidation and reduction, half reactions, etc. Okay, so just quickly to go over the work from yesterday, I'm just going to do the ones that are on the page here. So if I look at chlorine, Cl2, I'm going to make this bigger, so maybe I don't know if I can get numbers underneath here. But chlorine itself is going to be a 0 because it's an element. Just like S8 will also be 0 because it's an element. If I look at H2S, H we know is always 1 plus. Plus 1. So if I've got 2 plus 1s for the hydrogens, the sulfur has to be a minus 2. Let me just erase some of this stuff. Okay, so plus, oh, this is not working well. Plus 1 for hydrogen, minus 2 for sulfur. If I look at Na2O, it's an ionic compound because it's got a metal and a non-metal. I always know that oxygen is going to be minus 2 anyway, and sodium it has to be plus 1 because there's 2 of them, and I need to overcome the minus 2, so they've got to be plus 1s. But I also know that sodium is an alkali metal, which means it's always a plus 1 anyway. Remember, all the group 1 elements are always plus 1. If I continue over to the side here, I see this one, which is an ionic compound, Fe2O3. So the 3 from down here must have been with the iron, because the 2 from down here was up with the oxygen. It would have been minus 2. So oxygen would have been minus 2. While the iron would have had an ionic charge of plus 3. We're not going to do H here because they've thrown it in just to be miserable. CO2, I see oxygen, which is always minus 2. And if there are 2 minus 2s, carbon has to be plus 4. If I keep going across here, I see a fluoride ion, F minus. Remember, ions are always the same as their ionic charge. So fluoride would be minus 1. If I move down to the ones below here, for HClO3, I know H is always plus 1. I know O is always minus 2. Okay, so if I have to add them up, I've got 3 negative 2s for the 3 oxygens. That makes minus 6. And I only have 1 plus for hydrogen, so that means my chlorine has to be plus 5. So I can have 6 pluses for the 6 minuses. The next one down there is KNO2. Oxygen is always minus 2. K is a group 1 element, so it's always plus 1. So again, looking, I've got 2 oxygens, which are minus 2 each. So there's negative 4, and I only have 1 plus, so nitrogen must be plus 3. So I can have 4 pluses for the 4 minuses. If I look at Na2CO3, I see oxygen, always minus 2. Sodium, which is always plus 1 because it's a group 1 element. Now if I look at the carbon, I'm seeing I have 3 negative 2s for oxygen, which makes minus 6. And I have 2 pluses for sodium, so I must have plus 4 for carbon, so that I've got 6 pluses and 6 minuses. I'm going to come back to C in a minute and E in a minute. Let's go to F. F I see is an ionic compound. So if it's an ionic compound, the Fe would have been 3 plus, because the 3 from down here would have gone up beside the iron, and the negative 1 beside the iron would have gone up for the nitrate. So the Fe becomes plus 3. Oops. Oxygen's always minus 2. Okay, so this is where we're going to get a little bit tricky. Notice that the NO3 here, the nitrate, is an NO3 minus 1. That's what it is. It's nitrate NO3 minus 1. So if I've got 3 oxygens, which makes minus 6, but I need to have 1 minus left over, nitrogen has to be plus 5. Okay, that's a tricky one. I'm going to do C and E a little bit differently. So for C, I know that the charge from sulfur, oxidation numbers for sulfur, plus 3 oxygens will add up to the charge, which is negative 2. Okay? 1 sulfur plus 3 oxygens makes negative 2. I know the oxygens are always minus 2. Let's just push this up a little bit. Oxygens are always minus 2. Sulfur is unknown at this point, and it has to equal negative 2. So 3 negative 2's on the left makes negative 6. I'm going to bring them across to this side as plus 6. Okay, get rid of them on this side. So sulfur equals 6 minus 2, which is plus 4. So the sulfur becomes plus 4, and the oxygen is always minus 2. Same with ClO4 minus, right? If I look at ClO4 minus, up here I've got 4 oxygens and a chlorine have to make up minus 1. So the chlorine plus 4 oxygens make up minus 1. But I know oxygen's always minus 2. So chlorine plus 4 oxygens make up minus 1, which is the charge on the ion. I've got 4 times negative 2 here, which makes negative 8. So I'm going to bring it across to this side as plus 8. So my chlorine now is equal to negative 1 plus 8, or 8 minus 1, which means plus 7. So the chlorine here is plus 7. Okay, so now note that, note that the chlorine over here was plus 5, and the chlorine here is plus 7. So remember, different elements aren't always the same. Oxygen's always minus 2, hydrogen's always plus 1, but other ones don't always have to be the same. Okay, so our short note today is section 9.4 in the textbook. Okay, and that is oxidizing and reducing agents. Now, the reaction that we started this whole unit with was zinc reacting with copper to make zinc ions plus elemental copper. And what we said was is the copper here is copper 2 plus a sulfate 2 minus. Boy, when this doesn't work, it doesn't work. And over here, my zinc sulfate turns into a zinc ion 2 plus a sulfate ion 2 minus. Okay, so notice I've got sulfates on both sides, so I can cancel them. So I'm left with zinc plus copper 2 plus on the left, and zinc 2 plus copper on the right. Now notice that the copper 2 plus is going to turn from being a copper 2 plus ion on this side to elemental copper on this side. So the half reaction is down here, and it says that the copper 2 plus is going to turn into copper. How do I do that? I have 2 pluses on this side and nothing on this side, so I have to add 2 minuses to get rid of the 2 pluses on this side. So there's my GUR reaction, there's my reduction. The copper is gaining electrons. The zinc, up here is turning into zinc 2 plus on the other side. How does that happen? The zinc, in order to become a 2 plus, it has to lose some negative charge. Now, again, remember, a bit of a trick to doing this is to look at the charge that I have on this side, which is 0. The charge I have on this side is plus 2. So how do I make the plus 2 equal to 0? I guess I have to add 2 negatives to this side, so 2 electrons to this side. Okay, so the zinc is being oxidized because it is losing 2 of its electrons. Now, so if the copper is being reduced, right, while the copper gets reduced, right, it's going from copper 2 plus to elemental copper here, what the copper 2 plus is doing is it's forcing the zinc to be oxidized. That's what the copper is doing. When it gets reduced, it is forcing the zinc to be oxidized. Remember, one has to be reduced when the other one has to be oxidized. So if the copper is being reduced, what it's doing is it's forcing the zinc to be oxidized. So we call copper an oxidizing agent. This is probably the trickiest concept in this entire chapter 9-10, is what you see right here. Oops. Right here. The thing that gets reduced, right? The thing that gets reduced is called an oxidizing agent. And the zinc, which is being oxidized up here, the zinc is losing electrons to become zinc 2 plus. How does it get oxidized? It forces the copper to be reduced. Right? It forces the copper 2 plus to take electrons on. So if the zinc is being oxidized, it is going to reduce the copper 2 plus. So the thing that gets oxidized is called a reducing agent. Okay, that is the trickiest two points in this entire unit. So just try and keep those two terms straight, because the textbook spends quite a bit of time talking about oxidizing agents and reducing agents. And just remember, whatever is being oxidized is a reducing agent. Right? Whatever is being oxidized is a reducing agent. And whatever is being reduced in the reaction, it's called an oxidizing agent. Right? So go with that for now. If you're finding that way too much to get your head around, then don't worry too much about it. But that's kind of the way we talk about the different oxidized and reduced components in the reaction. Okay, the last topic in this section 9.4 is looking at whether or not a reaction itself is actually a redox reaction or not. Okay, and this is important because we need to look at the reaction and say, is anything being oxidized and reduced in this chemical reaction? Because in some chemical reactions, it is redox. And in some chemical reactions, they're not redox. So I need to be able to look at the reaction and decide if it's redox or not. So how do I do that? Well, I'm going to look at the oxidation numbers in the reaction, and if the reoxidation numbers change from one side to the other, then I know that it is a redox reaction. Right? If oxidation numbers change, that means something has been oxidized and something has been reduced. Okay, so let's look at an example here, and then I'm going to basically leave it for the night. Okay, so the first sample is zinc reacting with sulfur to become zinc sulfide. If I look at the oxidation numbers, I'm going to write it up here. I'm going to make it bigger, actually. Zinc reacting with sulfur to make zinc sulfide. Now, the zinc was 0 because it's an element. Sulfur was 0 because it's an element. This is an ionic compound. It contains a metal and a nonmetal. So that being the case, I'm just going to look at their ionic charges. On the periodic table, it tells me zinc is always 2 plus and sulfur is always 2 minus. So the zinc would have been plus 2, sulfur would have been minus 2, and the answer is yes, this was a redox reaction. Because the zinc changed oxidation numbers and the sulfur changed oxidation numbers. Now, if I move down to the second reaction, it says SO3 reacts with H2O to make H2SO4. So let's look at our oxidation numbers. For the first compound, I see oxygen all the way across. So oxygen's always -2. So let's just put in my oxygens. And hydrogen's always +1. So let's put in my hydrogens. And now let's come back and put in the one missing one, which is sulfur. So at the beginning here, I can see the sulfur. If there are 3 -2s, 3 oxygens, I've got -6 then. Sulfur must be +6. If I look over here, I'm seeing there are 4 oxygens, which are -2s. That's -8. But I've got 2 +1s already. So I guess I need 8 minus 2. I need 6 more pluses, so the sulfur is +6. So notice the sulfur doesn't change oxidation number. It's +6 on both sides. The oxygen never changes oxidation number, and the hydrogen doesn't. This is not a redox reaction. So this one was a redox reaction, and the other one wasn't a redox reaction. Okay, the next equation down. KClO3 reacting to make KCl plus O2. Now, I was going to do the ones that I know for sure. Oxygen here is -2. Oops, undo. Oxygen is -2. Oxygen here is -2. No, it's not. Remember, oxygen on the right side here is just an element. It's just O2. It's just oxygen. So it has 0 oxidation number. So I know automatically that this is a redox reaction because I can see the oxygen changes oxidation number. What about the rest of them? Okay, well, let's look at the potassiums. Potassiums are group 1 elements, so I wouldn't have to go any further. I could just say it is redox because the oxygen changes oxidation number. How about potassium? Potassium is a group 1 element, so according to the rules, it's always +1. KCl is an ionic compound where the K is +1 and the chloride must be -1. What about the chlorine on the left side? So I've got 3 oxygens and each one is -2. So that's -6. And I have a potassium which gives me 1 plus. So chlorine must be +5. I'm missing 5 pluses here to make it neutral. So notice that the chlorine is changing its oxidation number, and the oxygen is changing its oxidation number. Right? The oxygen is actually LEO, it's losing electrons, and the chlorine is GER, it's gaining electrons. All right, so let's... Okay, so I'm going to stop there. There's a whole bunch here, so what you need to do for each one is just basically make them bigger, right? And then just decide, are oxidation numbers changing? Right? So first one, hydrogen's an element, chlorine's an element. Hydrogen here is in a compound, so it's got to be +1. So chlorine has to be -1. So I can see the hydrogen changes, the chlorine changes. So yes, this is a redox reaction. Move down to the next one. Okay, so you're just going to follow those 7 rules for oxidation numbers and then try and decide whether the reaction was redox or not. Okay, so that basically finishes up this note for 9.4. There's a bunch of questions here now. Okay, there's a bunch of questions down here. I'm going to ask you to try 1 to 6 here. All right, so 1 to 6 are down here. And then in our textbook, there's another questions 1 to 8 in our textbook. Okay, so quite a bit of homework, but you see most of it's pretty fast. You're just getting used to those rules. Keep them out, keep them handy. Just remember, whenever you see something, whenever you're trying to decide, right, just very quickly look. I see an element here. I see an element here. I see hydrogen in a compound. I see oxygen in a compound. I see oxygen in a compound, right? And then just try and do some of the figuring out to decide what the last missing oxidation number is up there. Okay, and then this one says which one is oxidized and which one is reduced. I didn't really do that before. If I go back up to the ones that were oxidation reactions. Okay, so look at this one here for a minute. Oxygen's going from 0, hydrogen's going from 0 to +1. How do I go from 0 to +1? I must lose an electron, Leo. The chlorine goes from 0 to -1. How do I go to -1? I must gain an electron, Ger. Right, so the chlorine is Ger. Oops. And the hydrogen, H2, is the one that's being oxidized. All right, let's go back. This one here, I can see that the potassium isn't changing. It's +1 on both sides. The chlorine is going from +5 to -1. Right? How do I go from +5 to -1? I have to add 6 negatives to chlorine to go from +5 all the way down to -1. So it's gaining electrons. So the chlorine is the Ger, and the oxygen is actually the Leo. I'm going from -2 to 0. How do I go from -2 to 0? I have to lose some negatives. I have to lose some electrons. So the oxygen here is the Leo. Okay, so it's an actual element, not the whole compound, because there's only one compound on the left. Part of the compound, the KClO3, is being reduced, and part of that compound, some of the atoms are being oxidized while some of those atoms are being reduced. Okay, this one up here, zinc we said was 0, sulfur is 0, zinc was +2, sulfide is -2. So sulfur is going from 0 to -2. In other words, it's gaining some negative. And the zinc is going from 0 to +2, which means it's gaining positive. I can't gain positives. I must be losing negatives. Okay, so